In this video, we're going to continue our notes on section 2.6 and look at example 2. So here we want to find the critical points of our function and then graph our function to determine if those critical points are a local extrema, meaning a local max or min. So first step we need to do is just compute the derivative of our function. So we want to compute f prime of x. So please pause the video before continuing and try this to compute this derivative on your own first. All right, when you're ready, let's look together. So to compute the derivative here, we have a power and a composition. So we're going to use the power rule with the chain rule. So the power comes down, so we get 3 times x squared minus 1 squared, since we remove 1 from that exponent. Then we're going to multiply by the derivative of that inside function. So the derivative of x squared minus 1 is just 2 times x. Now, just to clean this up a little bit, I'm going to combine my like terms. So I have a 3 multiplied by a binomial, multiplied by a 2, multiplied by an x. So we see I have 2 numbers here that I can multiply together. So 3 times 2 gives me 6. We go ahead and move the x over 2, just so that it's a bit more clean, times x squared minus 1 squared. So now to find the critical points, I want to find those x values where f prime of x is equal to 0. And let's also check, are these going to be the only critical points? Nope. We also want to ask, is our derivative undefined anywhere? So take a look at this derivative. Are there any x values that we cannot plug in? Nope. So we have no undefined values. So we only need to check in this case where the derivative is 0. So to find those x values, we're going to set 0 equal to 6x times x squared minus 1 all squared. So here we have a product equal to 0. So in order to get this product equal to 0, at least one of these terms is going to be equal to 0. So that would mean either x is equal to 0 or x squared minus 1 equals 0. So that gives us x equals 0 or x squared minus 1 equals 0. So this second equation would tell us that x would equal 1 or negative 1. Because if we plugged a negative 1 into x here and squared it, we get a positive 1. Subtracting 1 would make it 0. So to summarize then, what are our critical values? So our critical values are at x equals 0, 1, or negative 1. So now let's take another look over at our Desmos calculator to determine if these critical values are local maximum or minimum. So just to recall again, into our Desmos calculator, we want to put our original function. We're not going to graph the derivative because the critical points or the zeros of the derivative tell us the critical points of our function. But we want to actually determine local max and min. So I take x squared minus 1 and parentheses to the power of 3. All right, so what do we got going on here? So first, let's find those critical points on our graph. So we see that negative 1, 0, and 1 are the critical points that we found. And we see that there are also critical points on the graph, meaning the derivative at those points are 0. So at negative 1, do we have a local max or min? No, because on the left we increase, on the right we decrease. So at that point, we don't have a local max or min. What about at 0? Yeah, because on the left, we are, or from the left, we've decreased, then we increase. So at x equals 0, we do have a local max, or local min rather. Good catch. And when x equals 1, no local extrema. So going back to our notes, we can summarize. At x equals 0, we have a local min, but no local extrema at x equals -1 or 1. All right, great work.